Thank you, Ronald, for the introduction. Actually, it's not only the current state, but also a look into the future, how SUMO can develop in the topic of bicycle modeling. So, as we already have heard today, for example, by Kai Axhausen, that cycling is a big topic in terms of sustainable traffic and matching the climate goals. So, for example, in European cities, cycling is is used very frequently. So we have cities which have 20% of people, 20% of trips covered by biking, and we want to get further. And obviously, we as researchers and working on traffic simulation also want to contribute to this and make our simulation better in terms of modeling cyclists. As already introduced, for example, also by Heather and others today, traffic simulation developed more out of car traffic. So a lot of existing models may not match the needs we feel we need for bikers. So what Heather talked about, like about the strict rules or following the path or not following the path, is one of the things we have to think of, and generally allowing some degrees of freedom for bicycle traffic. So some topics were already covered by Heather, but this is more of a large overview on some of SUMO, and I've structured this in these several parts. So when we have the following a lane, so longitudinal and lateral movements along a lane, along a street. We have intersection, which we already have seen by Heather. We have more general topics, which I named here network, and we have routing issues. So let's start with the following behavior. You already know we have several car following models, and that's already the name, car following models. In SUMO, among them, for example, Krauss and IDM. And we also use them for modeling bikers following each other currently, because we have no dedicated, and because maybe for some purpose, for some situations, they also match the purpose. On the right side, you see just a small figure about how some speed curve of the IDM model of several users following each other. So this is more or less the current state, because mostly we would use car following models currently in SUMO as a general purpose. In terms of fast pedestrian, or Heather also introduced this, like choosing between car and pedestrian models, we currently have only some very basic pedestrian movement models, which could in theory also be used in some cases, but maybe are not the best choice. During the work with the University of Wuppertal, we also thought about how to develop it further in the terms of following behavior, and found some interesting topics. So one topic overall is empirical data for sure, so that we can also discover first cycling behavior and validate it afterwards. And then there are others like influences in lateral movements, so that the following and the lateral movements are sometimes interconnected. For example, if you want to ride next to your friend, then there could be other situations. And generally the topic of calibration validation. Currently, there is no integrated social force model in SUMO, but you could develop your own, or we are in the means of connecting another simulation which does this. Now we follow on to the lateral movements, which are, I already said, are somehow related. You already got introduced to the sublane model, which means that if you divide the lane into smaller sublanes, you can let cyclists ride next to each other, or in a kind of offset shape. And lateral movements also occur for generally in SUMO for navigation purpose, so follow a route, for speed gain, for cooperation, and other rules. That is the current state, but what could we do? What are some topics which we could enhance regarding lateral movements with bikes? So one discussion was about like the, which was already also mentioned here in this discussion, like either the interpersonal or intrapersonal preferences, differences in regarding different situations. For example, regarding the safety distance, the minimum gap. And one thing I always have to refer to Heather because she was first introduced a lot of concepts. But she didn't mention it. She already showed it, is how to model the cyclists in the 2D view. So what kind of space do they occupy? At the moment, it's a box shape, but wouldn't be a diamond shape be better? So a diamond shape where, I don't know if I can place the mouse here. So just that the space they occupy where they sit on the bike is larger, and on the ends it gets smaller. So that they also could write maybe diagonally at the offset, and just what you don't see here because they just, okay. So they just keep more distance than they maybe would in reality. Yeah, thank you. I think I already explained it, but okay, doesn't matter. Okay. Okay. So that's the thing about lateral movements, our ideas, and I think the intersections, we already saw this picture, so we also noticed that there are these topics like the left turns and the compliance with rules. And another topic, which is now more SUMO specific, is the conflict areas, how they are modeled. So currently, there was a lot of the conflict area for bicyclists was much larger than necessary, but I think we will change this or already changed that.
It's not done yet.
Not done yet? Okay, so it's in the near future. So that cyclists will not leave a large space if they can just cross the intersection before the other participants. And then we thought about, other stuff. So one idea would also be that as a cyclist, you do not cycle very fast. You can see what in front, what is happening at the intersection. And for example, hurry up if you see that you can still cross the intersection, or if you see another cyclist coming from the side, slow down a little bit instead of coming to a stop. So driving a little bit with of a tactical view to adapt your speed, to avoid to come to a standstill because this needs more physical force to start again. And now we leave the single network elements and come to the routing. There are a lot of ideas how you can make it more complicated or integrate some arguments which are essential to bikers but not to other road participants. In general, the routing in SUMO is done by some effort, some weight value which is associated with the parts of the road network, for example, the edges. In general, it's the travel time. And what already is possible to actually also use the bike speed in routing. So that is one option we already have. But some more smaller things are like that bicyclists could circumvent an obstacle. So imagine there's someone parking on the bike lane and you have the pedestrian lane next to you, which you should not use, but in real world you would. So to allow this in special cases, if you want this, some intermodal purpose, so that you can take the bike with you in public transport or walk next to it and have it available when you need it. and also like some roads which might not be possible, or at least not advisable for special types of bikes. So for example, cargo bikes, which are very heavy or very large, so that you don't want to carry it up some stairs or whatever. And yeah, that includes also to include all these attributes which could trigger this into the routing, like pavement, slope, and so on, to choose the route you prefer, because some researchers also do studies on what bikeability features actually make you choose one route over the other. So that is also one point in routing. And as a last, more as a general point, we have some positions regarding network overall. So some general things like whether something should become the default, like indirect left turns, and what about slope? So there is also already a dedicated car following model which integrates slope, but it's tied to the Krauss model, and this could be generalized. And e-bikes also offer a lot of new, or raise a lot of new questions, because bikers can adapt their speed, and also this has some effects on the flow, for example, but also raises questions in terms of charging your the battery and so on. Regarding slope, we have to think about where to get this data from. It's difficult, but there might be some information in OpenStreetMap. And also regarding bicycle lanes, it's not exactly in OpenStreetMap, but we could think about it in a heuristic which would give a good result in this respect. So now I presented a lot more, not actually the state, but a lot of questions, a lot of ideas, and we would be happy to get some return from your side. What do you think about it? If you have other ideas, more features you think of, or what you value the most, what is for you really important in this aspect, and also if you have some ideas of empirical data and how to calibrate and validate our models, which is always a big question. During the workshop, which originated, where this originated from, we did a kind of little ranking, and the 3 points which are listed here are a little bit those who had a good ratio of like easy to implement and also some value for the users. I think I was fast enough so that we can still discuss a lot of things. Thank you.